everybody, and welcome to another E5 podcast. I am one of your hosts. My name is Paul Meenan. Thank you for tuning in. And I am joined by both my tag team partners on the last, potentially, of this series covering Amendment 2. Introduce yourself, chaps.
Hello, I'm JW.
And it's David Watts, aka SparkyNinja.
That's it. The gang are all back together. David couldn't join us in the last sessions we were recording this. He was slightly preoccupied. Slightly, yes. Just dealing with life's challenges as they throw stones at our greenhouse. We finished at the end of part 6. So for those listening on the way to work, the next 2 parts of the regulations, we'll get into part 7, which is special installations or locations. Dave, do you want to start off since you're back in?
Well, I'm actually trying to figure out. I mean, I've just heard about a change in bathrooms, and I'm looking for it.
All right, okay.
So where is it?
So section 701, 702, and 703, bathrooms, swimming pools, and saunas.
Yeah.
It states where regulation 70, 1, 2, or 3, 414.3, sources for Selve and Pelve. The regulation states where Selve or Pelve is used in zones 1, 2, and 3, a source described in regulation 413, part 4, shall not be used.
Oh yes, well that's I remember that one. That is where a certain method of achieving Selve, where it uses electronics, and there's a potential in that source of Selve for a higher voltage to appear on the secondary, I believe, and they don't like that in the presence of water. Clearly.
Wonder why.
So one potential method of achieving protection against Selve is not suitable, which does mean we now need to be very careful with the way we achieve Selve.
Is this a new part of the regulation, or is this a rewording of the existing, Dave?
I'm pretty sure it's an exception now. Let's have a look. Hang on. I've got the actual main book in front of me. 701 Selve. What's the regulation number?
Well, it's actually 414.3 according to this.
414.3. That is.
But it's referenced in
book.
701.
That's not in the current book. It goes
701, 413.3.
Yeah, in the current book it goes 701, 414.4, and that's it.
Yeah,
it does.
Covered.
That's a new regulation.
So it's not in there. So it's a new thing.
Okay, so what's this new requirement for bathrooms then, chaps? If anyone can find where that is, or are we still swimming through treacle?
You're on about the distance?
Yeah.
Yeah, I've heard it. I'm just obviously I'm not seeing it in the document.
Yeah,
okay.
It's a single line. I've altered it.
701.512.3.
Yep, that's the one. So it was 3 meters for socket outlets from the edge of zone 1 or the edge of the bath, basically. And now it's 2.5 meters.
Yeah, it's sneaky. It's right at the end. It's hard to see.
Oh, it's right at the end. So 701, 512.3, socket outlets are prohibited within a distance of 2.5 horizontally from the boundary of zone 1.
Okay, so what is the significant reason that we actually now have taken taken half a meter off?
I've no idea, mate.
Yeah, I mean, if you look at the rest of Europe, they generally don't have this restriction at all. It's normally just outside the zones you can have sockets. So it's kind of a UK thing, but it's not a UK only regulation.
Surely somebody has appealed this. Somebody has said. I mean, is it maybe the typical cord set?
Well, we have everyone listening to this has the opportunity, or watching this has the opportunity to appeal it and write your comments. It's very difficult as well finding these new little bits from when we did our webinar, because the document that's out on the website doesn't highlight the changes. You have to read it line by line.
That's the problem. That's why I couldn't find that blooming difference just then. We can't see these.
No, we can't, because it's all one colour text, which is incredibly frustrating. But the BSEN numbers are in colour, which is even stranger.
Yeah.
And the problem is if it's a new sentence put in, you can usually spot it with the old one. But if it's just numbers change, it's really hard. But
why can't they have put into it the lines that we have in the existing book? In the book, we have those lines to show change. They could at least put those lines in the draft so that we can
the lines
see
on the
them.
boundary that shows
Yeah.
it's a new. Yeah, you know what? That's a
They're
valid
asking us
point.
to look at this huge document, which is hundreds of pages,
638 pages.
with no key indicators of where there is something that we need to actually see that's different.
So yeah, and the worst thing is 638. Current edition is basically 555. So it's a whopping great edition of
But the only way for you to review this properly is to read this word for word and to flick through the current book word.
This is why we had headaches on Monday and Tuesday, because it was just a nightmare using the online system. Luckily,
so coming back to this one, 2.5 meters. I don't know.
Yeah, I don't see the point.
I don't see the point of it.
Either we're going to stick with the 3 meters and not have sockets in bathrooms, or we're going to go down the route of the rest of the world pretty much and have sockets in bathrooms. So, which is it going to be? It seems to be
this is sockets other than self. And
this is your normal socket outlet.
This is your typical 13-amp socket. Paul, you said I do. So what do you think?
This is going to raise a lot more questions. This is going to. You can see this being explained in a revised guidance note 7, without a doubt. But I think a lot of installers will see this as a good thing. I see this as the first start of a slow. I've said this for a while now. When you've done 20 years in this industry and you've learned the regulations, and tutors especially will identify with this. When you've learned the regulations, you can see a systematic shift in the approach of things. When I started, RCDs were introduced as supplementary protection. Now they're mandated. This distance has gone from 3 meters to 2.5 meters. In 20, 25 years, it will probably be, as John said, probably half a meter. Why? Because over those 20 years, there will be a phased. There will be RCBOs everywhere, so the risk is lower. So they can reduce the risk and the distance in the regulations.
But here's the question, Paul: is the presence of having an RCD on the final circuit supplying the source of the equipment an answer to the risk of us plugging equipment in and going in the bath with it?
No.
But that's where that trend you've just described is going, surely.
Yeah, I know. It's scary. It depends on the equipment now, and that's the scary thing. There is potentially, and I'll say potentially kindly, potentially a gap in what we plug into the fixed installation and what we use as to what we're selecting and erecting. So I would love the mindset shift to include, and I don't know if I said this on a previous podcast on the webinar, when we talked about earth leakage, John. There are standards available, although they cost thousands of pounds to access, that define product leakage. Now that, in my professional opinion, should be an appendix in the back of the regulations with a list of all the products, common products you can get, with what their minimum and their maximum leakage is, along with the formulas for working out the installation leakage, so that the installer has the best chance to select and erect his RCDs accordingly. Years ago, 20 years ago, and I remember having this conversation with Electrical Safety Council when they were first formed.
A few years ago then.
Yeah, a few years. Oh, I feel old. But Electrical Safety Council said, no, all we really consider is the fixed wiring. Whatever people plug into is irrelevant. It's all resistive and inductive loads. It's not anymore. It's electronic. It's stuff that we know leaks by design into the fixed installation. So the installation has to consider the connected loads, the regulation on Type A RCDs, the regulation on earth leakage, the regulation on mutual compatibility, all tell us we need to be thinking about the connected loads. So the mindset of Sparks that learned 20 years ago, if it's the same as what it was 20 years ago, is wrong. We need to shift along that journey with the technology. Just a thought.
Yeah. The problem I've got with this whole bathroom sockets thing is the fact that at the moment it's the 3 meters, but the problem is that 3 meters does not extend outside the room. So if you have a little ensuite bathroom in your bedroom and it's a little tiny, like 6 by 4 foot room, you can quite allowably put a socket outlet on the wall in the bedroom side, right next to the door,
just plug it in,
which is virtually within a metre or so of the bath. But because it's not in the bathroom, it's permitted. But if your bathroom is, say, huge, you cannot have that in that same distance. It has to be 3 meters away. So the fact that zones don't go out of the doorway makes a mockery of the whole thing, really.
I mean, I remember when I used to work in a local authority on the voids, we were actually instructed by the NIC at the time, if there was a lot of the properties had, the separate toilets, bathroom in like flats and things, but they were right next to each other, and there was that wall between the two, and on that wall would be the light switch, 2-gang switch, one on the right for the bathroom, one on the left for the toilet, and believe it was a socket outlet. And we were told doing the void EI periodics at the time to always blank them off, because people would just plug in, and a typical extension lead, the typical 1 meter long, would then be able to get in underneath a door, which were always hovering above. There's no fire ceiling then, and they'd sit on the side of the bath. So we had to do that back then. It just seems today that we're kind of playing with this so much because maybe we're just relying too much on the way technology is evolving. But I don't know if our understanding of this technology is evolving with it.
What's frightening is, yes, I agree, our understanding of technology is somebody always has to die for this to change. And that's scary because no one should have to die. No one. And yeah, it's a scary thought process. Right, 704. Construction and demolition sites. Been on them a few times in my life. I'm sure all you boys have. 704-443. This is a new one, isn't it, Dave?
Yeah. This is obviously just increasing the consideration of overvoltage. This obviously is not to do with atmospheric transients. This is to do with switching over voltages. So yeah, it just says transient over voltage of atmospheric origin or due to switching, and then it gives an example: cranes, lifts, cement mixers, and similar items. Yeah, liable to produce switching over voltages.
And you're not going to get a better example of a high switching frequency than a construction site where power supplies dip into nothing other than site cabins, and then during peaks and troughs go absolutely bonkers with various trades plugging in. Although in fairness, do we get that as much now? Because most of the trades, the manual trades, are all cordless battery chargers.
A lot of it is, a lot of construction sites now try to go down the old battery cordless. Try to, a lot of sites really the only real electrical systems are lighting and things like that. A lot of the work is done with battery power. There are times though where battery power is just not enough.
I agree.
Batteries are fine up to a point, but if it's like some heavy duty thing you need, then maybe not.
It's mainly the civils boys who need it in it for this.
You got to get the work done, haven't you? At the end of the day, and you just can't achieve.
Although in fairness, nowadays to reduce that risk, it's all done off site and then just pumped up. In my career, I've actually been on a concrete pour. I've actually had to hold what they call the elephant's trunk from the concrete pour, and when that starts, it doesn't stop. And I'll tell you now, that hurt.
Yeah,
I was mocking the civil engineers, as you do when you're on site. You have banter, and I said, they were talking about wiring and doing conduit. So I said, I tell you what, next time you do some concrete, I'll show you how easy it is. Oh boy, it hurt. It hurt like hell. There are photos that exist, by the way, of me on a rebar with an elephant's trunk, screaming for people to help me because it was hard work. It really does have a kick to it. Okay, so moving on. 706, conducting location with restrictive movement. And this part of the regs they changed the name of it because it used to be restrictive conductive locations, didn't it? Or am I going bonkers? Am I literally going?
It
mad?
May have, but it's been conductive locations with restrictive movement, I think, since the 17th.
Oh, well, there you go.
For a while.
Yeah, that's me. That's me.
Sometimes people
part of the regs.
Sometimes people don't really understand exactly what is within this type of location. I don't know. Did we ever upload the podcast that you did with Richard where you talked about this?
It should be out at some point soon.
Yeah,
we did,
because it was good because we went through a couple of examples in that one. Because everyone thinks of this and they picture themselves to confined space training.
Yes.
Which obviously, a lot of people who do specialist work, they think of that. They don't think of other locations where this can come into account. But the actual addition here really is a method of additional protection with supplementary protective potential bonding, and it had this need to say if functional earthing is required, because obviously we're understanding that functional earthing is really starting to become more and more apparent. In the new code of practice, there's a whole new approach to functional earthing. We've got the symbols with that. It's going to be provided.
The new code of practice. This is
the PAT testing code.
Oh, do you know what? I've just received that the other day. I've got a highlighter pen on it, the cover ready to go.
Yeah, the code of practice for the in-service inspection and testing of electrical equipment.
I do like the fact that they've removed the term PAT testing. That's not a bad thing. I haven't read it yet. Does it clearly define the boundaries of what an installation is now, or is it a bolt on to part 6?
It's done a lot to try to help raise awareness of the different types of equipment that should still be within its scope. That always were within its scope, but were never approached. a lot of the industry kind of just rested on plugs and plug and that was it.
Yeah.
So it's got rid of that, but it has confused the issue with regards to fixed equipment maintenance. It does say within it that really the fixed equipment maintenance should be carried out under BS 7671. Things like continuity protective conductor tests on the ICRs should go to the exposed conductive parts of equipment, is worded within that code. Yeah, but obviously that's not within the way that we actually do the work,
not
is
within the inspection and testing
No.
specification either. So that's a dramatic change to part. Oh, that sounds like an Amendment 3.
Yeah, and
It really does.
Yeah, and they've got a couple of other little bits in there, such as different levels of competency. We should really do our own little chat on this sometime. But
let me read the book on it.
Yeah, it introduced a functional thing, and that's been added here to conductor location with restricted movement. It just, we know that the protective measure here is, if you're working in a confined space and you're in an environment around you that is conductive. But if this equipment is also going to have functional earthing, then there needs to be supplementary bonding there to equalize any potential differences for this functional earth.
So for those listening, functional earth, not a term we use much, is defined in 7671 as earthing of a point or points in a system or in an installation or in equipment for purposes other than electrical safety, such as for proper functioning of electrical equipment. And that's key. It's the correct functioning of the equipment. So functional earths, we find them now on RCBOs. A lot of them, although they removed them now on a lot of them, but the Schneider ones, they still have the functional earth on the back of the clip, which I'm showing on the YouTube video. I've actually highlighted it. That's a bit weird, isn't it? I've put a highlight pen on the side of a breaker, just because my eyesight is getting worse. But yeah, functional earthing is when functional earthing required. If you're going to see how much kit now is requiring connection, I think a lot of
equipment these days has the earth for the protective conductor purpose, but things like leakage current, we say equipment has an allowance of leakage current. I think a lot of equipment utilizes that for functional purpose, but has it undercover as a protective conductor current.
I think we're going to see a lot more of this certainly in that prosumer section. There's going to be a lot more functional earthing involved, because it's in that particular way it's pretty much essential if you're going to be switching between different suppliers and things.
And I completely agree with you, Dave. I do think that the protective conductor current or the leakage current is actually functional earthing of that piece of equipment, because it needs somewhere to go, and if it doesn't, where will it go other than just sit there and idly get hot and burn out equipment? At the end of the day, it needs to discharge that energy, otherwise the energy will build up. Right, moving on. I'm just going to leave this to you, Dave, because it's section 711.
Exhibition, shows and stands. They've added some extra protective requirements. Let me just read this one. This is 410.3.101. So 410 is protection against electric shock in there. So it says, except for final circuits of safety services, all final circuits not exceeding 32 amp that supply socket outlets, all final circuits for lighting, and final circuits supplying handheld equipment that has a rated current not exceeding 32 amp. So it's all final circuits up to 32 amp, basically, will be protected by ADS with an RCD to 30 milliamp. And it says in there, with additional protections, that's what the RCD is for. Supplied by SELV or PELV, or have electrical separation of circuits with each socket outlet and handheld equipment being supplied from individual isolating transformers. So this is where your 413 method of protection, electrical separation for one item of equipment only. It's just similar protective functions that they had in a couple of other areas of Part 7, where equipment that has up to 32 amp just needs protection by RCD, SELV, or electrical separation, really. And that's it, really. It's not nothing new, really. I think it's just something that wasn't well written before. More RCDs is going to be the common interpretation with that.
Yeah.
And when we look at events, RCDs, they just go hand in hand now.
So moving on, because there's another change to 711, isn't there?
There is a technical rewrite of the protection requirements for TN systems, because beforehand it said, we don't like PME. We don't want you to use PME. But if you use PME, you've got to make sure you've got supervised, skilled, instructed persons babysitting it. And you've got to make sure the effectiveness of that earthing is suitable for the event. They just didn't really like PME. Obviously, what they've done is they've introduced a regulation which is very, very, very similar to one of the ones to the latest TN system protection in section 722, which we'd have seen after Amendment 1, where we're looking at, and it just says, except for part of an installation within a building, a PME earthing facility shall not be used as the means of earthing of an installation falling within the scope of this section. So don't use PME, except where one of the following applies. So protection against electric shock is provided by a device. This device will disconnect the unit from the live conductors of the supply and from the protective earth in accordance with 543.3.3.1012, which is a disconnection of earthing there. This is within 5 seconds in the event of the voltage between the circuit protective conductor and earth exceeding 70 volts due to open circuit fault in the pen conductor of the low voltage network. This device need not operate if the voltage is to exceed 70 volts for a period of less than 4 seconds. So we're allowed to go over 70 for up to 4 seconds. It'll provide isolation with selected in accordance with table 537.4. Closing or resetting of this device is only possible if the voltage between the circuit protective conductor and earth has not exceeded this value of 70 volts. The alternative is another device of some form which achieves what we've just discussed. So, or equivalent safety. And we've seen this in part 7 in 722.
Yeah, this is a strange thing, really, because this is the one that needs some kind of probe or thing in the actual earth itself to measure the voltage between that and the electric conductors in the circuit. And then it's into the same can of worms as putting earth electrodes in, and how can't be near to the rest of the system and all of that. So it looks like just a copy and paste from the electric vehicle section, but they've only put in that one and then the alternative device.
Because obviously the electric vehicle section has had these new devices. They've put in these new alternative interpretations for TN system protection, but that's not come here. This is just talking about that one device that watches that monitors the voltage.
Yeah, and do you know where this 4 seconds things come from? Because I mean, is it perfectly okay to shock people for 4 seconds and kill them, and then if it's longer than 5, that's fine, you can disconnect? But that's a very strange time length to allow a dangerous voltage to hang around, isn't it? But
yeah, it really is.
We need to find someone who knows more about this particular subject matter and ask them to come and explain it in English.
So I mean, the thing is, we know these new, we know these chargers are out there. We know they've got their own innovative methods, but they are not doing this. They're doing something else, aren't they?
Yeah, they're basically relying on the voltage between line and neutral going outside the normal range, which is reasonable in some circumstances, not all of them. But this is literally between the protective conductors and the actual earth itself. So, yeah.
But to have that, you're going to have this extra electrode for reference. And that's what's missing. You found a device once, didn't you, that had this? But
there was some charging thing that some company made, but it didn't make it clear exactly how it worked or what it was supposed to do. But it definitely had a sort of a probe that went into the ground and presumably monitored the voltage between the two. But it was all very vague and not very informative as to exactly what it worked with and whether it complied with any standard or not. So.
But the fact that it's coming in here into 711 and it's also mentioned in 717 suggests to me they are happy with this protective method or this device. So I'd really like to know exactly what it is that they're
I mean, the
bringing
principle
along
of
here.
it, the sort of principle of it is okay, but it requires you've got to have that electrode probe or whatever in the actual ground or the earth itself. And if you've got PME system nearby, that's got to be probably 10 meters plus away from any other extraneous parts in the ground that are connected to it. Otherwise, if the fault occurs, that voltage will just transfer across onto your sensing electrode and it won't work. So, and if you're going to be that far away and you're going to put electrodes in, why not just make it a TT anyway?
Yes,
which is what a lot of it's done anyhow. So.
Well, just for completeness, I read this out and I said protection against electric shock is provided by a device which disconnects the unit from the live conductors of the supply from the protective earth in accordance with 543.3.3.101. Just to complete this is with regards to switching devices installed in the protective conductor. It's an exception. So obviously we don't normally put switches in a protective conductor. One of the exceptions being where a multi-pole linked switching is in the protective conductor circuit, it's not integrated before the live conductor, and is re-established not later than when the live conductors are reconnected, which is, common understanding what we would want to achieve. We would never switch to protective conductor before the live conductors. We'd never make the live conductors before them. There's a
Yeah, it's an established thing. Certainly, like you had a 3-phase board and you inexplicably put a 4-pole isolator in, it has to be designed so that the neutral remains connected longer than the other 3. Otherwise, bad things happen, to say the least. So
that's what that longer regulation mentioned in this is all about. I don't know. Maybe we can do a little journey just to see if we can trigger, pinpoint this device down, or maybe we can see if anyone's up for approaching us to talk about it more.
So if you just carry on, because I'm just reading a document. I'm reading effects of current on human beings and livestock.
Are you looking for 4-2?
I'm looking because I read something somewhere that made the statement effectively to cause ventricular fibrillation, you need a minimum of 500 milliamp for a certain amount of time. And then when you look at where the 30 milliamp come from, it relates to pigs and sheep and animals and various other bits. But I'll be honest with you, I'm not this German scientist who have written all of these wonderful white papers that have contributed to this standard, but I'm just trying to find that reference. So just crack on through. 712.
So that 4 seconds. I mean, it's any voltage over 70, so you could have like 200 volts there for 4 seconds. That's fine, apparently, which seems excessive to say the least. But
yeah, I mean,
there's a reason for it somewhere. So
yeah, I mean,
to me, in my hand.
To me, especially in exhibitions where there's going to be lots of portable equipment, lots of distribution around, this is a little bit scary to think about this, because this could be, an earth that's also connected to structures and all sorts. And if this voltage could rise to that value for a period of over 4 seconds and within 5, it's more than enough time. Should we push on while Paul reads?
Yeah, go for it. Go on.
Yeah,
Sorry.
we'll move on to the next, because it's basically a copy and paste from the vehicle section, so the same problems that are included there. So moving on then, it's 712, which is PV or photovoltaic power supply systems. And
we kind of looked at this and we understood. I mean, it says in the scope this applies to installations of PV generators that supply all or part of the installation and feeding of the electricity into the public grid or local distribution. The equipment of the PV generator, like any other item of equipment, is dealt with only so far as its selection and application in the installation is concerned. The installation of the generator starts from the PV module or set of PV modules connected in series with their cables, provided by the module manufacturer up to the user installation and utility supply point. This has been quite an exhaustive rewrite of scope.
There's a lot of expanded and sort of covers a lot more stuff now than it did before.
And I think obviously they're anticipating that people are going to revisit 712, quite a few people, and I expect that this is probably due to prosumer being a new direction for BS 7671, and so people are going to have to reapproach solar. A lot of people who may be doing solar now are putting in the array and they're obviously connecting it to the grid, but when it comes to prosumer, there's a slight adjustment.
Yeah, there's a couple of big changes really in terms of that. I mean, the prosumer situation allows you to run in island mode, which means when there's a power failure, your solar generator doesn't actually shut down. It continues powering your installation, but is separated from the grid. And the other thing is that until relatively recently, certainly for domestic installations, they're all basically limited to about 3 or 3.5 kilowatts, because that was the maximum you were allowed to get when you had the feed-in tariff, where it was given 41 pence a unit.
Yeah.
But the thing is, now that tariff has gone away, there's no reason not to put a much bigger system on your house. If
that's true. There's probably a lot of arrays out there that are actually smaller than they could potentially be because of the cap on what you can actually have.
So if you've got a big roof, why not put a 10 kilowatt array there?
More on.
Why not? I mean, it's free electricity, isn't it, basically? So that artificial limit on the size of it has gone now. So we could be seeing a lot bigger installations coming in for even domestic ones.
I think we're going to talk about more about prosumer soon, but I can see solar. Solar is a separate subject. It's definitely a separate subject from the typical electrotechnical apprenticeship. The training needs to update, definitely. And it needs to kind of either be modular with smart homes or something for the sake of prosumer installers. But I think a lot of electricians are going to have to start relooking at solar, and it will probably in the next year or so whilst this is being considered. there'll be lots of new approaches to solar and methods of installation, and even training courses being created, I think.
Yeah, I think so. And unfortunately, a lot of the solar installations that were done in the past under the massive subsidy scheme were done by companies which just popped up and appeared out of nowhere, banged in a load of solar stuff, and then disappeared just as quickly. So,
well, I remember when the government announced a deadline, a lot of companies just popped up to get the contracts and to get the things arranged and get things signed up, and some installations still didn't happen for months after the fact. Because everyone was just capitalizing on the feed-in tariff and before it got dropped. So we've got a couple of little things in 7.12. We've got a mention about safety of the generator itself, and it had an interesting note that said applicable national or local fire protection requirements apply under thermal effects. So I need to look more into what that's actually pointing at. I mean, is it just pointing at national fire standards? Are we looking at fire safety reform order? I mean, what else could there be for that? So, and then we've got under thermal effects in there as well. It's talking about the potential of insulation faults on the D side on the array, and the consideration of insulation monitoring devices. I see insulation monitoring devices becoming more of a popular point raised in BS 7671 over quite a broad spectrum, but a lot of electricians still haven't even heard of them or installed them.
Yeah, so, I think it's another. I mean, they've existed for a long time, but it's not something that most people have even seen. But given the complexity of installations that's now coming into, I think it's inevitable we're going to be seeing a lot more of that type of equipment, which is basically a thing that sits there and actually monitors the installation continuously for certain types of faults.
And to be honest, I mean, it could be that installing IMDs in installations could be a good idea because it might save a lot of IR testing and stuff. Yeah,
and certainly for things like solar installations on the DC, because if you got your a rat chewed through the solar cables on the roof and they short together, ultimately you're not going to detect that with your conventional circuit breakers and things. So, but if you do that, the cable's going to get hot, melt, and potentially set on fire. So,
the last place we want fires to start.
These devices that monitor the actual installation, it's like a leakage current in a kind of way, but I think that's going to be fairly inevitable.
And another little interesting one was where functional bonding is applied to the live conductor inside the inverter on the DC side. Means will be provided to ensure the interruption of the fault current in case of an installation fault worth in accordance with table 7.12.537. So it brought this term of functional bonding, which we've had to kind of research to understand, because it's not really something that we often consider as a functional.
Well, I think Amendment 2, there's a comment right there, isn't it? Is do we need to redefine what functional bonding is? Because the inference given within them chapters infers that the equipment is now opting to use functional bonding internally, which is going to use the protective conductor.
Yeah, and the thing is, how are you going to know whether that equipment has got it? Because obviously decent manufacturers may well put it in, but obviously if you buy some lower cost and unusually sourced item, then who's to say what's going on inside? So there's a lot in there sort of along product standards and things as well, which
and there's in 7.12.43 is overcurrent protection. There's been an introduction of a lot of scenarios based on overcurrent protection here, and we're not going to go through it in this podcast. We do need to do a dedicated study on this, just kind of bring it in as a standard, as a single regulation, I think, where you're looking at the number of strings and you're looking at the actual arrangement, and then you're working out the short circuit current that can occur. Again, this will probably be one of the main study points with training to get short circuit protection.
So I will make a request to a PV expert and see if I can get him to do an emergency ad hoc one where we just talk about PV, because it's definitely worth talking about. So I'll make a phone call, shake the tree.
The problem with short circuit current on solar panels is that even if you get the two leads and literally run them together in full sun, the actual amount of current there is pretty low compared to what you get from a normal installation. So it's not just a question of sticking your normal circuit breakers in there and it trips off, because it won't. So
Exactly.
Oh, the panels now are getting quite efficient. They're a lot more efficient than what they were 10 years ago. A hell of a lot more.
Oh yeah, but so if you short out your main supply at home, you're going to have what, a couple of thousand amps there.
Oh yeah.
Short
I mean,
out
when we were first started delivering training on this, we would actually short out solar panels to actually measure the ISC.
Yeah.
It was one of the practicals that we did. We'd go out, we'd take the panel, we'd point at the right angle, and we'd take a measurement. No, we'd short it out. So yeah, but they're probably a lot more efficient these days.
So I have done my reading, chaps. If we
You've done your reading?
Done my reading. So published document 6519, published in 1988, also known as IEC 647 Part 1, 1984. It's called Guide to Effects of Current Passing Through the Human Body. And it's fascinating because what it does do is it introduces new terms like threshold of perception, threshold of let go, threshold of ventricular fibrillation, which in our language is heart attack. And it interestingly says threshold of perception, a general value of 0.5 milliamps, independent of time, is assumed. That's interesting. I didn't know that. Threshold of let go, a value of about 10 milliamps is assumed within this guidance note. The threshold of ventricular fibrillation depends on psychological parameters. There are 4 psychological zones in regards to effects of electric shock. And anatomy of the body, state of cardiac fluctuations, etc., as well as electrical parameters, duration, pathway, current flow, kind of currents, etc. For shock durations below 0.1 second, fibrillation may occur for current magnitudes above 500 milliamps. So 500 milliamps, 0.1 seconds. If it's over 500 milliamp, less than 0.1 of a second, you're going to get a heart attack. Interesting that we consider it 30 milliamps. Still haven't found that little gem, by the way. It then says, in adapting these results from animal experiments to human being, curves were created. The high level of short durations of exposure between 10 milliseconds and 100 milliseconds was chosen as the descending line from 500 milliamp down to 400 milliamp. On the basis of electrical accident information, lower durations longer than 1 second was chosen as a descending line from 50 milliamp to 40 milliamp. And then it mentions 3 seconds, but it doesn't state what happens after 3 seconds.
How old is this?
This is 1988. This is probably, there is a German chap whose video we have who tried to kill himself in 1959, and he evidently has been Knollvalven, WB Knickerbocker, G. Chesant, R. Milner. I can't even pronounce all the rest of these names, but there's lots of people who've written loads and loads of papers experimenting on animals. And it does actually state at the very start, because it gives a value of total impedance of the human body is averaged 500 ohms for the 5th percentile of the population. But at a touch voltage, there's an actual table for total body impedance. At 50 volts, you can either be in 5% of the population and have a total impedance of 1,450 ohms, or in 95% of the population have a total body impedance of 4,375 ohms. So, yeah,
this is why they come up with standard rules of thumb, don't they? You know, I mean,
it's interesting because it even says when voltage hits the skin, the impedance of the skin will break down, temperatures will change. This is, of all the standards I've read. This is the most interesting one, but it does state that obviously not many human beings have been experimented on. It doesn't say no human beings have been experimented on. It just kind of says it's very limited.
And subsequently, they need to then test on the state. I mean, you mentioned the state of, there's age, there's health, there's state of, respiration. There's it could be wet at work. And this is like I do when I do courses. I cover the threshold of perception, so those are all familiar terms to me.
So there's one,
but it's still it's an old standard. And
there's a chapter called Effects of DC Current. Starts off with saying accidents with DC current are much less frequent than would be expected from the number of DC applications. This was written in 1974. We're using DC all the time.
Yeah. The problem is there. The attitude of that was in regards to the use of DC back then.
And it says, unlike AC, there is no definable threshold of let go for DC current of magnitudes below 300 milliamp. Above approximately 300 milliamp of DC, let go may be impossible or only possible after several seconds or minutes of shock duration. Bloody hell. 300 milliamps of DC is a sensation of warmth felt in the extremities during the flow of current. Oof. Oh, what a weird read. This standard is IEC 479 Part 1, General Aspects, Effect of Current Passing Through the Human Body. I highlight stuff when I read it.
I've got about half a dozen standards and things about effects of human body, so I may have that one.
This is part 1.
I need to look at them.
It's part 1. That's the only one. I'm going to be perfectly honest. The reason it took so long is I don't understand any of the other parts because it's pure maths and.
Well, there's loads of tables. There's loads of tests. So coming back to this was all about why 4 seconds over 70 volts?
I can't see anything in this. Yeah, I've looked for 70 volts. I can't find anything. Yeah. So I think that perhaps the science needs to be looked at again, but by whom? Bisra, Beamer, who? I don't know.
My concern is they're probably referring to a standard that is old or a study that is old that may not be used considering the utilization of electrical systems today.
Of course it is, without a doubt.
And so when you think about that, it might not be as safe as they consider. But who knows? It might be that this is worst case, that they're kind of giving a little bit, that they do that when they don't have an exact number. They always just give you a little nudge.
Maybe someone listening to this can actually go away and ask the question in the nosebleeds of the electrical industry. Have we updated that 1974 original piece of research for DC being used everywhere and, accident statistics and coroner's reports and various other modern progresses of technology and science?
And please let us know. Please educate us. Please help us. Because we'd like to understand when we see the regulations say it's okay up to 4 seconds. We want to know why. We want to know why so we can explain, We want
to explain to ourselves so we can share that understanding that way.
So we can assess risk and we can do all this stuff.
We can make better decisions as well, Dave, at the end of the day, isn't it? That's the key thing.
It's like when I do a health and safety training, I don't go fuses protect people. I don't go RCDs protect people. I go through ventricular fibrillation. I go through threshold of perception. I go through the different levels of current so they can then see why that 30 milliamp has been used. And that's basic stuff. But when we come to this kind of device, we need the same.
Yeah.
We need to understand the difference as to why 4 seconds but not more. Why no more than 5? Why 70 volts?
I agree. Right, where were we? Sorry,
we were just about to finish 712, and we were just talking right at the end of 712 in 443. They've added a requirement to consider over voltage protection.
Fantastic! I'm doing it at the moment as it's. I knew this was coming, so I've already got this on my stuff.
Yeah.
And how did you know it was coming, Paul?
Because I did my due diligence, which some people think I don't do, but I do. And I looked ahead into the future in my crystal ball and revised everything around the number 60364 and then just added a part or a number. And when I saw a standard that was draft for public comment, I would download it and read it and go, there's a technical intent there. I see the logic well explained. That potentially
and with that same approach, we saw in those European standards 60364, these countries that were abandoning Type A CRCDs.
We did. We've also seen the
same thing.
We've also seen the fact that the fundamental principles has had quite a major rewrite as well, but it's not in Amendment 2 yet. So I'm quite excited, if that is a term I can use, for Amendment 3 and the 19th edition.
We've got all of next year for people to chew on this, and at least we've got other work to do looking at the next one. Trying to keep ourselves
and I know it sounds really weird, and I know a lot of people criticize its manufacturers. It's a cash. I find this stuff quite exciting in respects of it's great to see technology growing as a tool. It's sad to see us kind of lagging around the rest of the world when I'm a big believer in, buy British, invest in British technology and everything else like that, and British manufacturers and companies and, employ local people and apprenticeships and all that. It would be nice if we can maybe start steering the ship back to a stronger footing as far as UK manufacturing going and being leaders and not followers in that sense. That would be pretty cool if we can get there. Yeah. It will take decades, but it'd be nice to put that direction in the auto pilot and push the button. That'd be pretty cool.
Okay. Next one that had a big change is in 717, which is mobile or transportable units, which again are used in events and similar. And this is again TN systems. A PME earthing facility should not be used and except one of the following. And it adds This unit is located indoors or it's outdoors but on an upper story or a roof. So not obviously in the car park or out on the grass. Or it then recovers the regulation we've just been discussing in exhibition shows and stands. This device that achieves protection and disconnection of the protective conductor within 5 seconds, or no, within 4 seconds, but no longer than 5, etc. Same thing. Copy and paste, as John would say, from 722.
Yeah,
It is.
and it's the same thing. And other than it being on the roof, then it's the same stuff. So,
but it's the common theme, though, that Amendment 2 is hinting that PME is a. When I say PME, I'll use the correct terminology. TNCS as a earthing facility is not reliable nor robust anymore due to the age of the network. PME is basically 40 years old now, if not a little bit older than 40 years. The design life for the TNCS original concentric cabling was 40 years. They're coming to the end of their life. We know we have more instances of broken pen. We know that the PME part of that CNE cable is only where the electrodes are spiked. We know from having seen recent evidence where the DNOs do joints on CNE cables, which combine neutral and earth, that they're not putting earth rods in where they should do. We know that the network's in a very poor state, and we also know that the old PILC TNS cabling has been adapted and changed to be pen cables. They've jointed, they've used concentric, joined it onto PILC, so your neutral and earth now in the street are one and the same, regardless of the age of the cable, which makes it even more potentially hazardous. Yes. They're just sticking a sticky plaster over the issue, aren't they, really?
And the thing is, we've seen a couple of documents that have actually said that to that effect.
Yes.
I can think of VS7909 as one example, which was published in 2011, where it basically says that they are, PME are sometimes repaired, or TNS are sometimes repaired as PME. Yeah, it is. It's
this way. It's. I think something's going to go, and I've spoken to the people in the JPEL committee about this. And it's fairly evident that the networks are crumbling and they're failing. That something needs to be done. I think the future in generations' time will be TT in some form, or maybe just a reliance on the new foundation earth electrode.
Well, again, yeah. I mean, if you think about foundation earth electrodes and prosumer, I think a lot of it is going to be protection should be independent of the distributor. And
the worst thing is, and I'll say this is the worst thing is. Even with that, even with our own local earthing, you've still got the problem of the neutral and earth are shared. So you can still have a broken neutral. You can still have that hazard appear. Now, the biggest challenge, and I find it slightly ironic that everything is now RCPOs. So we're required to have RCPOs on every circuit now, pretty much. And yet, in the event of a broken pen, it won't see that fault. So is this technology going to have to adapt? Now, we've been looking at this technology. And if you look at the Schneider or the Square D stuff, it's fairly evident that for maybe nearly 20 years, these devices have had the capability of monitoring a rise in voltage on the neutral of 50 volts and then tripping. Although it's been buried.
It's been a moot subject, clearly, that the industry just can't tell us or open up about this problem of OPEN. Electric vehicle clearly did. Because of that, because of the application of that, but as you say, that device has been out for decades.
Well, Schneider call it voltage. They've got two terms now, haven't they? Voltage independent technology and voltage dependent technology, which is kind of like latching and non-latching RCDs in the event of this broken pen. But effectively, what it does is, from what I can understand, and we're still probing them, is the neutral and an earth, the functional earth. There's some sort of link that occurs to allow it to get a steady reading so it can monitor the secondary side of the RCD and still protect. But again, why is all of this adaptation having to be done by the consumer in their installation for a network failing? And Mr. Skirm, his views on it have always been very clear, and that is every time you get a broken pen, £1 million fine to the DNOs. They'll soon upgrade the infrastructure and sort it out.
Yeah, I can't argue with that.
No, I can't either.
The back end of 717 is an annex, which is also on, I think, 711, which just talks about this PME, the pen failure, and it's similar to stuff from section 722. So we don't need to go through all of that.
Doesn't it mention, though, a separation distance of at least 8 meters?
It does.
To reduce voltage transfer.
8 meters? Yes. It refers
Then
to
we're told 2
7430.
meters.
In
Yeah.
conditions where only buried, exposed, and extraneous conductive parts equivalent to vertical and horizontal earth electrodes are being considered, the separation distance of at least 8 meters reduces the voltage transfer from the PME earthing system to less than 20%. And in these conditions, the voltage operated device should operate at 56 volts within a separation distance of 2 meters. The voltage operated device should operate at 40 volts. Therefore, where other types of earth electrodes are used, separation distances should be increased. So, voltage operated device. This is what you've just been talking about. I can't think of the last time. I mean, other than a VOE-LCB.
That
Indeed.
was the last time, which was
We've got-
84. That was taken out. So, well, 81 actually, but then it's hang around for a bit.
Coming back.
Yeah, I mean,
But the key there is this distance between other parts that are connected to the PME earthing system, because the closer you get to them, the more voltage is going to be transferred across, and the lower thing it's got to operate at. And if you get too close, it's going to trip randomly and all over the place anyhow. So it's this. If you're going to go for 8 meters away, you might as well make it a TT and sling the PME away anyhow, because you're going to have to put all your electrodes in anyway. So is this device even worth having if you're going to have to put it that far away? So.
And this is what I'm considering at the moment, is with my house, considering just putting in a series of electrodes so that I can have my own earthing, and then when I get the power supply upgraded, just bring the line of neutral in and just ditch the PME completely. Brand new cable, fully insulated.
Pipes as well.
You are?
Ditch the metal water pipes as well.
Oh no, I love my metal water pipe. I love my lead water pipes. No, I don't actually. I'll eventually do them as well in time. Yeah, so not really much faith in the whole TNCS.
It all looks a bit sort of rushed and panicked in at the last minute, and here's some solutions which might work some of the time, and not really thought through all that well. So
it does. And the thing is, I mean, for me, a lot of this stuff, a lot of the way that we have to then measure and test and all that is probably outside of an electrician's skill set from apprenticeships, from college. So there's going to be a bit more learning to do this accurately, and probably will be some resistance to that.
Yeah, I agree.
I mean, even the thing about just testing earth electrodes doesn't seem to be that well covered. And
No,
that's not
often it's just they draw it, they don't even do it.
So I mean, that's the fairly basic thing. But once you get into like distances from other parts and the voltage and so there's a lot.
What I'm miffed about is the amount of references we're now making to other standards in depth. BS 999, as we covered in an earlier podcast, BS 7430 heavily referenced.
Heavily.
You know, they've now gone from a reference of you might want to consider these standards to you have to consider these standards. So anyone who's really wanting to comply with the intent of especially special occasions, 7430 is going to become an essential standard to have.
Yeah.
I should imagine that there'll be a guidebook written.
Well, hopefully the guidance notes will. Well, let's be honest about it. The guidance notes will have to be updated to incorporate all this stuff.
Yeah,
I'm assuming.
Yeah, I should imagine they probably have their own specific guidance on this.
Right. Moving on very quickly then. EV charging. Anything in that?
Well, there's one, and there's a problem with this, which we'll just get to. Basically, we've got a new bit, which is 722.826.3201, which refers to things in Part 8. And it's where a device complying with one of those devices that you can have is used to protect EV charge equipment in a prosumer's electrical installation. And the vehicle shall be electrically disconnected from the live conductors of the supply and from protective earth in accordance with some regulation. So essentially, when you go into island mode where you're running on your own power, your electric vehicle has to be disconnected from the earth connection or from the supplier. Now, the problem here is that 722.826.3201 refers to 826.3201, which you would expect to find in Part 8. It's not there. So it's not in it. So
826.3201 isn't there?
No, it doesn't exist. There's an 8263,
right,
but there is no 826.3201. So what? Can I explain that? Yeah.
Okay.
So
these books need to be gone through a lot more thoroughly before they get released for draft, because effectively we're doing their spell check, grammar check, and their reg checking for them.
That
It's
other
not really
regulation
the intent
mentioned
of it,
in
is it?
there, the other regulation mentioned in there was that same switching device that we covered in the previous multiple
great.
latching device that obviously breaks the protective conductor first and makes the breaks the protective conductor last and makes the protective conductor first.
Yeah.
So this isn't new. This isn't new, by the way. This switching out of the protective conductor was in the 16th edition.
Yeah. It's just a method of switching. It's just
edition,
a method.
yes, for generators and other sets.
In the webinar, which we did a couple of days ago, somebody actually asked about disconnecting the protective earth conductor, and I couldn't find it in there at the time. And this is why. It's because 8263201 isn't there. So what's going on there?
Super smashing great.
So yeah, so we've got it in the 72 bit, but the actual thing in 826, no, there's nothing there. So
right.
Well done.
So okay, right. So lads, in a summary, part 7. What do you think? Summed up part 7.
Some of the overvoltage protective requirements make sense. Expanding the need for SPDs,
positive.
that's fine. The device that we've covered here, that's in 711 and 717, that comes from 722. This, no more than 4 seconds or over 4 seconds, no more than 5 seconds, 70 volts. I want to learn more about that. I want to understand more about why that is there.
Oh.
Yeah.
Okay.
The 2.5 meters for a socket from the bathroom. I just kind of go, why? I just kind of, there must be a reason.
We'll find out in time. If you know, let us know.
Yeah, there must be a reason. Maybe the cord sets have changed. Maybe the low voltage directive says cord sets will now be this. I don't know. Maybe there's a change about to happen about the length of cord sets. I doubt it very much.
Half a meter, it's not really make any difference to anybody, is it?
No. And so solar is adapting itself for prosumer. It's adapting itself to be a bit more complicated, but
which it needs to be, I think.
Which it needs to, and I think if electricians are going to be carrying on rewiring houses, and they want to in the same one package offer for a homeowner a complete rewire, including the electric vehicle charging point, they'll do a course, including a solar array, they'll do a course, including a prosumer electrical installation. They're going to have to combine all of this, and we need to improve the standards of solar. The reporting of solar, definitely. So it's a good step, but I'd like to kind of see it all packaged together a bit more.
It will be interesting to see how this all comes out once all the comments are revised and what the final product looks like, which we'll find out in March 2022 when it's scheduled for release. John, quick summary. What do you think?
Yeah, I think there's a lot in there which needs looking at further. For example, on the electric vehicle charging, the Annex A722 has been totally rewritten, so that needs looking into in some detail. And things like the solar is going to be, it's fairly big already in some areas, but it's going to be massive. It's going to end up being pretty much a standard thing on houses, particularly. So what's in there now is pretty much sort of an overview of the briefest parts of it. So yeah, there's going to be a lot more involved there in the future. So
fair enough. Right, I was hoping to get part 8 covered. Not a chance in this podcast, so we'll be back again for a part 8, and that will finish up our roundup post webinar of the 18th edition. So on behalf of the lads, until the next one, take care of yourself and each other. Bye bye.
See ya.
Bye.